Okay, so if you can actually hear me, I would like you to react by saying you are here because the class has started. Today we are going to be studying something very important, and that is pH and pOH. We'll probably extend the study into calculations in thermodynamics depending on how much time we have. But if you can hear me, please react. Okay, so having said that, uh, as we discussed in the last class, we have to continue. The concept of pH simply describes the measure of acidity or alkalinity. So when you hear the term pH, you're just trying to describe the measure of acidity or alkalinity. Now, having said that, it's important to take note of the fact that this is just a layman's definition of the concept. It doesn't necessarily describe it in details. But before we get into a more detailed description of the concept of pH and pOH, I think we should have a little understanding of some things. Now, the things that are important to take note of, as I said before, are number one, ionic product constant of water. So I'm reiterating, ionic product constant of water. So I told you guys that the ionic product constant of water is equals 10 raised to power minus 14. So just have that in mind, that anytime you hear the term ionic product constant is equals 10 raised to power minus 14. And how did we get this value? It is actually a value that is gotten from the auto-ionization of water. And remember, for those of you that are writing, you write auto-ionization is simply described as the ionization process in which two molecules of the same substance react to produce ions. So when you have water molecule, for instance, reacting with water molecule, automatically you will notice that it is going to give H3O plus and OH minus, which are both ions, and this process now is what we refer to as an auto-ionization process. It's not necessarily an emphasis, but it's just important you know this. Anyway, now the ionic product constant of water is simply the equilibrium constant for an ionization process of water. So once I look at the equilibrium constant for this particular reaction, I will simply get the ionic product constant. So we said yesterday that the ionic product constant of water, which is the equilibrium constant for this reaction, will now be simply equals concentration of H3O plus raised to power 1, we don't need to indicate that, multiplied by concentration of OH minus raised to power 1. We now said dividing it by these two guys are liquid, so you are going to have 1 times 1, which is going to eventually still leave us here. So the conclusion of that statement is the ionic product constant of water is equals concentration of H3O plus times concentration of OH minus. Now, have this in mind that we said that this ionic product constant, which is K of W, just know that this thing now is equals our K of W. This particular guy, his value or its value is 10 raised to power minus 14. And once you have that, you find out that 10 raised to power minus 14 is equals this times this. So, with this now, the other way of representing this is, instead of writing the hydroxonium ion, you simply represent it by writing hydrogen ion. So have that in mind. Hydroxonium ions and hydrogen ions are not necessarily the same thing, but they have equivalent values. Okay, so which means instead of writing it like this, I can write it like this. 10 raised to power minus 14 will now be equals concentration of hydrogen ion multiplied by concentration of OH minus, and I have that. So please take note of this thing, because we are going to be using it all through our relations. Even if you do not understand the whole story here, just put this to head, that 10 raised to power minus 14 is the value of the ionic product constant, and it is equals the concentration of hydroxonium ion times hydroxyl, or you say ionic product constant of water is equals concentration of hydrogen ion times concentration of hydroxyl. So for those of you that are writing, please take note. If you have a confusion, this is the time to put it out so that I can continue, because this is just the introductory part of the study. Okay, Favor said I should repeat the definition. Now, autoionization is simply described as, I'll take it again, autoionization is simply described as an ionization process in which two different neutral molecules of the same substance react to produce ions. Ionization process in which two different neutral molecules of the same substance react to produce ions. It's not necessarily a major thing to note, but the most important thing you need to note from this thing is the values and how it is gotten. When you are looking for the ionic product constant of water, just note that it is giving us 10 raised to power minus 14, and that 10 raised to power minus 14 is equals concentration of hydrogen times concentration of hydroxyl ion. Now, I might not be using, I will be using hydrogen ion and hydroxyl ion interchangeably. So have that in mind, that when I say hydrogen ion, I actually still mean hydroxonium ion. Okay, so far I hope this is understood, and I would like to move ahead. Now, with that said, we've gotten a very important point, and with this point we can extend this study to talk about one other thing. Now, given that you have 10 raised to power minus 14 equals concentration of hydrogen ion times concentration of hydroxyl ion, how does this relate to acidity and alkalinity? The first thing I would like to say is that if the concentration of hydrogen ion is greater than the concentration of hydroxyl ion, automatically this solution would be acidic. I might not have mentioned this before, but please, it is important you note that whatever makes an acid is not the other parts of the acid. Imagine we have something like HCl now. What makes this HCl an acid is not Cl, it's simply this hydrogen. If you have H2SO4, what makes H2SO4 an acid is not SO4, it's simply this hydrogen. So just have that in mind, that anytime you are dealing with an acid, the emphasis of an acid is the hydrogen ion. Why I'm emphasizing this thing is because when we get to the calculation, sometimes they will give you concentration of the acid, but you don't need to use the concentration of the acid to do anything. What you need is the concentration of hydrogen ion. So I take it again, that in dealing with a particular solution, in an aqueous solution, if you notice that the concentration of hydrogen ion is greater than the concentration of hydroxyl ion, the implication is that that solution is acidic. Now, on the other hand, if the concentration of hydroxyl ion is now greater than the concentration of hydrogen ion, automatically it means that that solution is alkaline. And I guess with this we can come to the conclusion that if the concentration of hydroxyl ion is equal to the concentration of hydrogen ion, the solution is said to be neutral. So please have this in mind. When hydrogen ion is greater than OH, acidic. When OH is greater than hydrogen ion, alkaline. But when they are equal, it's said to be neutral. Now, how are we going to know if a particular solution is neutral on the basis of the concentration of hydrogen and hydroxyl ion? This can actually be solved mathematically, but before that, I hope you people are following. So let me just go and check out the questions so far. Okay, so far there is no question, and I presume if there's any question, please you can ask at this point. If there's any question, you can ask at this point. Okay, so if you are all following, please say I am following so that I can just continue. If this is fully understood, just type understood or say I'm following so that I can just continue. So Anyanwuchi Debere said I should re-explain the neutral. Okay, so just basically listen. If you look at your screen, the point is that hydrogen ion and hydroxyl ion basically are acidity and alkalinity. So the implication is that whenever you have hydrogen, which is for acid, greater than hydroxyl, which is for base, the acidity being hydrogen ion would overpower it and it becomes acidic. If hydroxyl is now greater, the alkalinity will overpower it. But if they are equal, practically you will notice something that it becomes the same thing. They balance off. Like the acidity cancels the alkalinity, and once acidity cancels alkalinity, it becomes neutral. So just have this in mind, that once their concentrations are the same thing, automatically you have a neutral solution. Okay, now having said that, I think I can now move ahead. Chukwuebuka Stanley, is it when they are less than 7? Then we've not gotten to that, Chukwuebuka. So just if you are going to be patient a little, we'll get to that bit. So I'm trying to take this as systematic as possible, so that when we get to questions, there will be no confusion. Now, having said this, solutions that are neutral actually have a constant value for their concentration of hydrogen and their concentration of hydroxyl, and it is something that we can find. How can we find it? Now, for a solution to be neutral, we have agreed that if a solution is neutral, the conc of OH must be equals the conc of hydrogen ion, which means if OH concentration equals X, hydrogen concentration would also be equals X. Now, this thing actually gives us an edge or an advantage. What is the edge? So if for instance we decide to, let's say we decide to find the value for the concentration of hydrogen and hydroxyl for a neutral solution, how it is going to be found is quite simple. What do? We equate it to this particular equation. Now our concentration of hydroxyl ion will now be X, that of hydrogen ion will be X. And why are they X? Because they are equal. So whatever X becomes the value will be the same thing for both of them. So we'll now have 10 raised to power minus 14 would be equals, the concentration of hydrogen in this question or in this expression is X, so we put X, multiplied by the concentration of hydroxyl is X, so we put X. Now X times X is going to give us 10 raised to power minus 14 equals X squared. For you to understand this, please, I hope you are conversant with your indices and logarithm. And if you are conversant with your indices and logarithm, you will notice that if you want to remove the power of an unknown, what you do is, if the power is 2, you multiply both sides by 1/2. And through this, if you don't understand how to solve it, just look up indices. However, the emphasis is not on how to solve it, the emphasis is on the final answer for this particular study. So you find out that if you're going to remove this, you square root both sides, that is times both sides by raised to power half, and what you're going to get is 10 raised to power minus 14 times 1/2 is going to be equals X raised to power 2 times 1/2. Cancelling out and cancelling out, you will now notice that X is equals 10 raised to power minus 7. Now what does this expression mean? It means that for the solution to be neutral, the concentration of OH minus must always be equals 10 raised to power minus 7 mole per dmq, while the concentration of hydrogen ion must also be equals 10 raised to power minus 7 mole per dmq. So if you guys happen to come across a question, and in the question they say given that the concentration of hydrogen and hydroxyl ion is maybe they say given that the concentration of hydroxyl ion is 10 raised to power minus 7, determine the type of solution. I take it again. If the concentration of hydrogen ion is 10 raised to power minus 7, what type of solution is it? Option A, neutral. Option B, acidic. Option C, alkaline. Option A, neutral. Option B, acidic. Option C, alkaline. So what do we think? A, neutral. B, acidic. C, alkaline. So what's our answer? Put out your answer so that I will know that you're actually following what I'm doing. So put out your answers. Is it A, B, or C? I said if the concentration of hydrogen ion in the solution is 10 raised to power minus 7, what type of solution is that? Is it alkaline, acidic? Is it neutral A, acidic B, or alkaline C? So put it out. I'm waiting for those of you that are yet to do that. Now remember, if you are not following, please indicate. Yes, Peace Obio has said neutral, and yes, she is correct. The rest of you, I hope you guys are here with me. Put out your answers. What do you think? I said if the concentration is 10 raised to power minus 7, is it going to be neutral? Is it going to be acidic or alkaline? Okay, neutral. Go big is correct. Is that Prizipet? Yes, Shuku Prizipet is correct, and that's that. Now, I think I can now move ahead. Now, these are just the basic introductory parts, but once you understand these parts, it becomes easy to move ahead. Now, I hope you guys are also writing these things down. Now let's take this out and then extend the study. Now, having mentioned these things about concentration and its relation to ionic product constant of water, I would simply like to say that this particular description is just a relationship between concentration of the two ions and ionic product constant of water. However, we need to understand the relationship between the concentration of hydrogen ion inside an acid and then also the concentration of hydroxyl ion inside a base because most times there could be some discrepancies with respect to that. Okay, now let me explain what I mean. Anytime you are asked to find the concentration of an ion, the concentration of an ion is simply the concentration of the dissolved substance multiplied by the number of moles of the ion. Any ion you have and you are asked to find the concentration of the ion, you just look at the substance that produced that ion, its concentration, and multiply by the number of moles of the ion. Okay, so what do I mean? Imagine, for instance, that I have a dissolution of H2SO4, and when I dissolve it, now on a normal, H2SO4 is a strong acid, and the implication is that it should undergo complete dissociation to give H plus HSO4 minus. I do not want to complicate things for you, but it's important you take note of the fact that this is how this reaction should go. It should give hydrogen ion first, and then this particular HSO4 will now further break down. If it further breaks down, you are now going to get the remaining hydrogen and SO4 2 minus. However, this particular HSO4 is not a strong acid, which means not every hydrogen ion would actually come out. But for the sake of this study and for an easier understanding, we are going to assume that once H2SO4 dissociates, all of the hydrogen ion comes out. So because of that, I will write the equation in this manner. I'll write it like this. Instead of writing like this, is the actual way to write it. However, because of the exam and how the curriculum and how we are being taught pH for JAMB exams, if you use this, you are likely going to get a lot of confusion. So when H2SO4 dissociates, just assume that it would give 2 hydrogen ions plus 1 SO4 2 minus. So you find out that in this case you have 2 hydrogen ions. If something like HNO3 dissociates, we would assume that it's going to give 1 H plus NO3 minus. So let's understand why I brought up this particular formula. So far, if you're following, please indicate. If you're confused, this is not the time to just keep following, because by the time we've not gotten to the part where it's tricky, you might not be getting what I'm saying now, but just keep following and we'll get to what I actually want you to take note of. Now, the most important thing you need to take note of in all these things, as I said, is the equation I wrote, or the formula I wrote. The formula I wrote, which is, once you are looking for the concentration of an ion, you do the dissolved substance times number of moles of the ion. Okay, so let's do this. Now, if I am looking for the concentration of hydrogen ion in H2SO4, how do I find it? I think it's quite simple or easy to solve. What do? I will simply say concentration of hydrogen ion is going to be equals the concentration of, what did I dissolve in this case? H2SO4. So which means concentration of the acid multiplied by the number of moles of hydrogen ion. So I hope this is clear. Now when you are looking for the concentration of hydrogen ion, it is simply equals the concentration of the acid multiplied by the number of moles of hydrogen ion, and you get that. I would like to just put out a question. Let me quickly find that question and then put it out. I saw that question earlier on today. That should be JAM 1992. Okay, let me see if I can find it. Okay, but while I'm looking for that question, you guys should try this question out. What is, I believe you can see it, is the concentration of hydrogen ion in H2SO4 if the concentration of the acid is equals 0.5 mole per dmq. So let's find this. So what is the concentration of hydrogen ion? Everybody solve and give me their answers quickly while I get this other question. So what do we think is the answer? I think I've seen it. This will be 1992 JAM question 2. Okay. I'll be putting out the question in a jiffy. Let me just upload it to my system. Name it. So what do we think of acid? Okay. So let me just put out the question so that everybody can see it. Yeah, your answers are not coming up yet, and I'm expecting them. So put out your answers. What do we think is going to be the concentration of hydrogen ion? So while you are doing that, let me just quickly put this up to the group. Okay. Yes. Go big 1, peace 1, chuku prezi 1. That's correct. Okay, so let me just quickly get this question. The system is acting up a little bit, but let's just be patient. The question will come up in a bit. Okay, while we are waiting for the question, so basically the implication of this statement is, okay, 1. Yes, so everyone that said 1, the answer is correct. And yes. So how was it solved? Quite simple. Remember, whenever you are looking for the concentration of hydrogen ion, what you do is concentration of acid times the number of moles of hydrogen ions. Now, if we happen to have a dissociation process, what it is going to give us is 2 of H plus SO4 2 minus. Hence, we have that the concentration of hydrogen ion is going to be equal. Concentration of the acid was given as 0.5 molarity multiplied by the number of moles of the hydrogen ion is 2. So what do we have? 1 molarity. Now, I would like to say something. If you are looking at the concept of molar conc has multiple units. You either see it as mole per dmq, or you see it as capital M, or you mention or you see the term molarity. We are not discussing volumetric analysis in this video, but it's important to take note of this. Whenever you see capital M or mole per dmq, it indicates the molarity or molar conc. Please, if you happen to see a question where they said 0.5 moles, this moles is not a concentration, it's simply the amount in moles. So you will need to dissolve this particular thing in a solvent or in water to get a concentration. We are still going to get to those parts, but so far I presume we understood this. Okay, so the question I wanted to put out for us to try, okay, so let's it's coming up in, okay, yes, let me add it now. Just give me 2 minutes. 2 minutes. No, 2 minutes is too much. Just 1 minute. My system was acting up a bit, so I couldn't access it. Okay, I think. Hold on. Pictures. A B C D E F G H. Okay. Okay. Oh yes. Okay. So the question will be coming up in 5, 4, 3, 2, 1. So let's all attempt this question. Let's attempt it and tell me what we think about the question. What do we think about the question? How many moles of hydrogen ions are in 1 dm cube of 0.5 molarity solution of H2SO4? What do we think is the answer? Yes, what do we think is the answer? Is this one for this question or for the older one? Okay. Yes. Are we there? Okay. So what do we think is the answer? Mm-hmm. Okay. Chukwuebuka, so yes. Yeah, thanks for the response. So yes, what's the answer? What do we think is our answer? I'm trying to take it as slow and systematic as possible. Someone says she thinks it's C. Okay, that's just some favor. Nice attempt. Chukwuebuka Stanley says it's 1, which is B. Nice attempt. Okay. Okay. I think one more answer and I'll solve. One more answer and I'll solve. One more answer. A. Okay. So Go Big and Chuku Pricey think it's A. Okay, so let me solve this question. Now, if we happen to look at that question, it says how many moles of hydrogen ion. It did not ask for the concentration, but it's important to take note that to find the number of moles, you actually need to use concentration. But let's calm down on that. How many moles, not the concentration, but moles are there in 1 dm cube of 0.5 molarity solution of H2SO4? So let's solve this together. Now, what you are asked to find is number of moles of H plus. We don't know. What you are given to find it is concentration of H2SO4, and the value is 0.5 molarity. Now, before I even go further, I would like to remind us that molar concentration is expressed as C equals number of moles times volume in dm cube. So for those of you that do not know, just know that molar concentration is represented by C is equals number of moles times volume in dm cube, which means that if we are looking for the number of moles, it will now be equals concentration divided by volume. No. What am I doing? This is a wrong expression. Sorry. Let's take that afresh. Concentration, I'm sorry, is equals number of moles divided by volume is in dmq. I'm sorry about that. Or concentration is equals number of moles divided by volume in cm3. Now, what this implies is that when you're now looking for the number of moles, is equals concentration times volume in dm3. Okay, in this case it's times 1000. This times 1000 all over 1. Let's leave this and come back to this. So just note that if you are given your volume in dmq and you are asked to find concentration, what you simply need to do is number of moles divided by volume in dmq. However, making n the subject of formula, you will simply have concentration times volume in DMQ. So far so good. I hope I'm making sense. Now remember what we wrote initially is we are looking for N of hydrogen ion. We're looking for N of hydrogen ion. Oh, yeah, that's true. I don't think you guys can see that part of the screen. I'm taking the question out. I hope everybody has it. I'm going to take the question out. Yes, so that we can all see what I'm writing. Now, as I was saying, that, sorry, let's go back to the board. Okay, good. So as I was saying, the number of moles of hydrogen ion is what we're looking for, and what we are given was the concentration of H2SO4, and the value is 0.5 molarity. Now what we can use this to find is simply the concentration of hydrogen. How? The concentration of hydrogen ion is equals the concentration of the acid multiplied by the number of moles of hydrogen ion. So look at it. The number of moles of hydrogen ion in the dissociation reaction is 2, and this is times the concentration of the acid, which is 0.5. so which means the concentration of hydrogen ion is equals 1 molarity. Now please remember, you are not asked to find the concentration of hydrogen ion, you are asked to find the number of moles. And when you are asked to find the number of moles is equals concentration times volume. If you look at the question, the number of moles of hydrogen ion will now be equals concentration, which we found would be 1 molarity multiplied by the volume in the question. They said in 1 dm3, the volume is 1 dm3, which means that what we're going to have is N of hydrogen equals 1 times 1, and what we're now, if you notice, molarity is 1 mole per dm cube. This is times 1 dm cube. So this dm cube cancels this dm cube, and what you have eventually is that the number of moles of hydrogen ion is equals 1 mole. Now why did I have to take you guys through all these steps? Because in some cases this volume might not be 1 dm cube, because you might be wondering, yeah, is it not 1 is it not the same? It's not the same thing. If this volume was 500 cm cube or 0.5 dm cube, your answer would have changed. So just have this in mind, take down these steps and follow it accordingly. The point is that you need to note that number of moles is equals concentration of a substance times the volume of the solution. You get? But then the emphasis in all these things I'm trying to say is to get you to understand that when you are looking for the concentration of hydrogen, it is going to be equals concentration of the acid times the number of moles of hydrogen ion. So far so good. I hope this is understood. Please, you guys should react. If you have a problem with confusion, do react. Okay, so I presume I can go ahead now. The implication of that statement, or what I just said, is that if, for instance, we now decide to find the concentration of hydroxyl in relation to base, concentration of hydroxyl ion is equals the concentration of the base multiplied by a number of moles of base in balanced equation. So you have that basically, that if for instance I had something like NaOH, if it's dissociating, it will give me Na plus, that's Na plus plus OH minus, and this simply implies that when I'm looking for the concentration of OH minus, it is going to be concentration of NaOH multiplied by how many OH do we have here? 1, and that's that. Now why I'm bringing up all these things is because the questions you might be seeing would have a lot of twists, and those twists are usually with respect to these things. So I hope this is fully understood. Now with that said, please put this down. I would like to now get into the main matter, which is pH and pOH, and at this point I presume we fully understand what I have explained so far. So we'll get into the ideal matters, which is pH and pOH. But before that, I'd like to say this. Yes, talking about concentration. Now, anytime you see a value, let's say you have 0.1 normality, you see it as just N, or you just see 0.1 normality. This particular value is giving the concentration of the ion, which means you don't need to multiply the concentration of the acid by anything. Once they say normality, just know that it's the concentration of the ion. So which means when you describe normality with respect to acids and base of acid is going to be concentration of hydrogen ion, while normality of base is equals concentration of hydroxyl ion. So the implication is, if I say that you have 0.1 normality of H2SO4, you don't need to do concentration of hydrogen ion equals concentration of H2SO4 multiplied by 2. Reason is this concentration that is in normality is not of H2SO4, is not necessarily the concentration of H2SO4. It is simply describing the concentration of the hydrogen inside H2SO4. So please note that when you see normality does not give the concentration of the acid. Normality is directly telling you that this particular guy has this concentration. So when you see normality of an acid, or they say 0.1 normality, it means that the concentration of the hydrogen ion is 0.1. If I see 0.4 normality of NaOH, I don't need to do concentration of NaOH times 1. Just know that this 0.1 normality has been solved and they have gotten the exact concentration of OH. So just have that in mind, that if you see normality, you don't need to do concentration of acid times number of moles of hydrogen, or concentration of base times number of moles of hydroxyl. That normality value is the exact concentration of the hydrogen ion or that of the hydroxyl ion. Please, I hope this is understood. Okay. Now, if you have questions, please put it out so I can respond to them. Chuku Prisi, sir, you don't understand. Can you please specify what you don't understand? Which of the solvings? Because I have solved one or two things here. Is it this one with respect to the normality? That's Chuku Prisi. Okay, so while Chuku Prisi, that's Prisi Pet is getting to that, I would like to go back to something that I probably mentioned but did not finish mentioning. Now, if you remember, we said 10 raised to power minus 14 is equals conc of hydrogen ion multiplied by conc of hydroxyl ion, and this is actually true, which means that whenever I am looking for the concentration of hydrogen ion, what I simply need to do is 10 raised to power minus 14 divided by the concentration of hydroxyl ion. And whenever, or on the other hand, if I'm looking for the concentration of hydroxyl ion, all I need to do is 10 raised to power minus 14 divided by the concentration of hydrogen ion. You know, this is just basically subject to formula. So please, I hope we understood. Please respond if you did. If you did, please say I understand. If you didn't, you respond. It's important we respond because it's a live class, it's online, I'm not with you guys. However, I know your response only by what you type. So please do type. If you don't understand, you say you don't understand. Yes, I'm still waiting for Principal to tell us the exact point. Or is it clarified? Should I just move ahead? Okay. Now, haven't mentioned this. I think we can now move ahead a little bit. Okay, let's try. Based on this thing I just said, try out this question. Imagine, for instance, I say, if the concentration of hydrogen ion is 0.001 mole per dm cube, what is the concentration of hydroxyl ion? Okay, so let's find that out. So everybody solve and give me their answer. Give me your answer quickly. If the concentration of hydrogen ion is that, what is the concentration of hydroxyl ion? Expecting your answers. Okay, still expecting your answers. Those that are online, please respond so we can move ahead. Okay, so yes, what's our answer? Does anybody have an answer so far? I'm not seeing any answer yet. Um, I know there's a lag time between um the live class here and online. So, but yes, is there any answer yet? Okay, just one answer and then I'll continue. Just get one answer and then I'll continue. So please give me the answer so that I can move ahead and be sure that we are all following the class. Okay, so I can see answers coming in. So let's solve it. 10 raised to power minus 10, 1 exponential 7. Okay, exponential minus 7, that's go big. Okay, let's solve the question. Let's see what happens. Now, remember I keep saying this, that whenever you see a question, the first thing you should ask yourself is, what was I given in the question? You get? And then the most important thing in that question is what you are asked to find. So first, let's identify solution. What were we asked to find? We are asked to find the concentration of hydroxyl ion. That's the first thing. And what were you given to find it? The concentration of hydrogen ion. And the value is 0.001, which is the same thing as 1 times 10 raised to power minus 3 mole per dm cube. Okay, so if we have this, let's kind of bring it into this. The relationship between OH and hydrogen ion is expressed as these three, but since we are looking for OH, we are going to be using number 3. You get? So that means that the concentration of OH minus, okay, let me kind of shift this so that so which means that the concentration of OH minus is going to be equals 10 raised to power minus 14 divided by the concentration of hydrogen. In this case, the concentration of hydrogen is the same thing as 10 raised to power minus 3. You know, if you know your indices, you know that this is the same thing. Besides, 1 times 10 raised to power minus 3 is still 10 raised to power minus 3. So what do we do here? They have a common base. So according to indices, this is going to be 10 raised to power minus 14. Division in indices means minus, and then we bring this guy in, bracket minus 3. And then what you're going to get as your final answer for the concentration of OH minus is 10 raised to power minus, that should be minus 11. So did anybody get 10 raised to power minus 11? And that should be the correct answer. You get? If you do not understand, please indicate. If you do not understand, please indicate. do not understand, please indicate. Now, Prissy Pet, I'm going to come back to that, but for now, I just need to finish up with some things. I'll respond to you in a jiffy. But so far, I hope what we just did now is understandable. Now, for those of you that might be confused with respect to the whole how did I solve this, how did I solve that, let me just advise you, if you don't understand indices, simply punch this directly into a calculator, directly. And when you are punching it into a calculator, put this whole thing into a bracket and this whole thing into a bracket while you are dividing. And once you do this, this is your answer straight up. You can do that and you will see what I'm saying. I don't have a calculator, like my camera can't see. I don't think you can see anything with this my webcam. So basically, so yes, I hope this is understood. Please, I would like you guys to respond. If you are in this class, please respond. Abiola, if na don't go sleep. Mona they talk, oh yeah, respond. As many of you people that are here, oh yeah, say I understand or I don't understand before I continue. Abi, should we cancel the class already? Oh yeah, oh yeah, oh. I'm still waiting for your responses. Once I have them, Chisom, it's not the same thing. Chisom, it's not the same thing as 10 raised to power. It's not the same thing as 10 raised to power minus 10. No, it's not. It's not. It's not. So you could say, if you had said uh 0.1 times 10 raised to power minus 10, then maybe, but not 1. You get what I'm saying? The answer is 1 times 10 raised to power minus 11 at most if you are putting 1. Then if you want it to be in power of minus 10, is 0.1 times 10 raised to power minus 10. So please, I hope and really hope that every one of you in this class has a good understanding of the concept of standard form, because if you don't, it's going to be an issue. You get? So please, you can actually review the class later. The link is out there for you guys, so you can review it later. However, I will need to move ahead of this. Now, moving ahead, we have touched the aspects that are usually the confusing parts, you get, or complicate questions. Now we are going to get into pH and pOH in details. Now, the term pH is a mathematical expression which is used as a measure of acidity and alkalinity, and it is mathematically described as pH is equals the negative logarithm to base 10 of the concentration of hydrogen ion. You could also say that pH is equals the negative logarithm to base 10 of the concentration of hydroxyl ion. Now, the pH scale basically runs from 0 to 14. Yes, let's have that. The pH scale basically runs from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Now, from 0 to below 7, from 0 to below 7, you have a pH that indicates acidity. I presume we know these things. Acidity. Then from above 7 to 14, it indicates alkalinity. Now, however, when you are considering the value of 7, gone, the exact value of 7 is neutral. So when they tell you that the pH is anything below 7, acidity, if the pH is anything above 7, alkaline, or when it is 7 on the dot, it is neutral. So you could have that in mind, that pH values greater than 7 indicate alkalinity. pH values less than 7 indicate acidity, and pH values equal to 7 indicates neutrality. So we are going to use that concentration we got to actually find that the pH equals 7 is neutral when we are done with understanding. What did I just write? Okay, please, this is not supposed to be no, sorry guys, this is not supposed to be hydroxyl. Sorry, this is out of it. Sorry, what I wanted to write was hydroxonium. So you have that pH is equals negative logarithm to base 10 of the concentration of hydroxonium ion. I'm so sorry about the mistake, but just have that in mind, that when you say pH, it's for hydrogen or hydroxonium. That's pH. Put it in your head. Now, why am I emphasizing this? It means that if you don't have the concentration of hydrogen, you can't find pH with this formula. I take it again. If you don't have the concentration of hydrogen, you can never find pH with this formula. So, if for instance I tell you that the concentration of hydroxyl ion was given in a question, you will not put it in this particular formula to find pH. The highest you can do is you will use that concentration of hydroxyl ion to find the concentration of hydrogen. That is, concentration of hydrogen is equals 10 raised to the minus 14 divided by the concentration of hydroxyl ion, and you use that hydroxyl to find H and then put it here. But as for putting hydroxyl concentration here, it is never going to work. So have that in mind, that whenever they say pH, it can never be overemphasized that it has to do with the negative log of the concentration of hydrogen. Now, did you notice that I also did not say concentration of the acid? I was specifically talking about the hydrogen ion. That is why I had to teach you how to find the concentration of hydrogen ion. So please, if you in the question have a hydroxyl concentration, don't put it here to find pH. You get where you actually put it in is when you are looking for pOH, which you are going to get to in a jiffy. But then running this thing through, when you say pH, please note pH is equals the negative log to base 10 of the concentration of hydrogen ion. And when you have a pH value of 0 to less than 7, acidity. When you have a pH greater than 7, alkalinity. But when that pH is equals 7, it indicates neutrality. I presume this is understood. If you have any question, please indicate. Okay, Nazi said I should redefine pH. Okay, now one other thing about this, Nazi, is as much as you just following, I think you can actually go back to the study and start afresh, because it will help you. You don't necessarily have to join us exactly. That's follow the class from where we are. Just to avoid taking us back, we've gone a little bit further. So you could go and start the video. Any confusions you have, you can directly chat me up. You have my number, or put it out to the group. Now, with this said, the emphasis in this particular screen is this, that pH is equals negative log. So now you get the definition now. pH is equals the negative log to base 10 of the concentration of hydrogen ion. If you don't want to write it like this, you write pH is equals the negative log to base 10 of the concentration of hydroxonium ion. So these two things are the definitions of pH. Now remember, I said if you don't have a concentration of hydrogen, do anything to find it and then put it here. Don't put any value here that is not the concentration of hydrogen. Okay, let's see what I mean. Imagine, for instance, let's see. Let me try to put out a question where that could help us understand this. Where is it? Okay, I think this. Okay, no, not that. Okay. Okay, let me just ask the question generally. Now, imagine, for instance, I'll get around to the questions. Now, imagine they said, what is the pH of a solution of 0.5 molarity HCl? How do we solve this? Very simple. pH is negative log of the concentration of H plus. Now, if you look at the question, they did not give us the concentration of the hydrogen ion, but they gave us the concentration of the acid. However, we know that it's still going to be 1 times this. You get. So let's find the concentration of hydrogen ion. The concentration of hydrogen ion is the concentration of the acid multiplied by how many hydrogen ion are inside the acid? Number of H plus. So which means that the concentration of hydrogen ion in this question is going to be, concentration of the acid is 0.5 molarity times the number of moles of hydrogen is 1. It's only 1 hydrogen you are seeing here now. So which means the concentration of hydrogen ion is going to be equals 0.5 molarity. Now, if we now put it here, it's now going to be pH equals negative log to base 10. We don't need to put base 10 to the concentration of hydrogen. The concentration of hydrogen is 0.5 molarity. Now, if we happen to put this directly in the calculator, what are we going to get? So I will still show you how to solve this without a calculator. You get, but let's use a calculator to solve this. So what we're going to get is negative log of 0.5. So our answer is going to be 0.301, and that's that basically about our pH. So the pH in this case is going to be 0.301, which is quite very low, and you find out that this is an acidic medium. You get. Why is it an acidic medium? Because the pH is less than 7. Once the pH is less than 7, automatically it's an acidic medium. So far, did you understand what we just did? Okay, yes, waiting for your responses. I hope we are still following. Those of us that are still awake, I hope we are still following. We have not gotten to the more complicated questions, but I want us to understand these things in parts. Is this understood? Please respond when I ask a question. Still waiting for our answers. I think with this we can move ahead into the other part, which is pOH. Now, having said this, let's take this out. When they say pOH, pH, as you said, pH is negative log to the extent of the conc of hydrogen ion. Now, if you have sense, you notice that pH is conc of negative log of concentration of hydrogen, which means pOH would now imply negative log of the concentration of hydroxyl. It's as if this P simply means negative log to base 10. So you have pH, negative log to base 10 of hydrogen. pOH will now be negative log to base 10 of hydroxyl ion. So please have that in mind. Now when you are asked to find the pOH, it is simply the same thing as pH. However, instead of using hydrogen ion, what you use is hydroxyl ion. So pOH, I take it finally, is the negative log to base 10 of the concentration of hydroxyl ion. I presume this is actually very simple to understand. And having stated this, we'll go to the extracts about pOH. Now, pOH is like an alternate of pH in virtually every way. If pH is going up, pOH is going down. If pH is acidic for this value, pH is alkaline for that same value. So please listen. Let's understand what we mean. Now, the pH scale still runs, the pOH scale still runs from pOH scale is equals 1 to 14. Now, when you have a pOH value greater than 7, instead of it indicating alkalinity as in the case of pH, greater than 7 in pOH indicates acidity. pOH less than 7 is now what indicates alkalinity. And finally, a pOH that is equal to 7 is also neutrality. So please don't get it twisted. Just understand that it's like an inverse of each other. That if the pH greater than 7 is alkaline, the pOH greater than 7 is acidic. Have that in mind. So just look through it over and over and then let it sink. It's not complicated. Don't get it twisted. Don't get it confused. Just note that the pH, if it is greater than 7 and it indicates alkalinity, when it is pOH greater than 7, it will not indicate alkalinity, it will indicate the opposite, which is acidity. So look through this and I hope you're understanding basically. Okay, so at this point I think I can move ahead because I think you all understood. Now I would like to say this, please, that just as I emphasized, if for instance you are given a question and that question you are not given hydroxyl ion concentration, please, you are not supposed to put it in pOH. If you are given hydrogen ion concentration and you are asked to find pOH, you use this to find the pH, and then we are going to now discuss how to relate pH to pOH. But please, when you look at the question and what they give you is hydroxyl ion concentration is only used for pOH. If they now give you hydrogen ion concentration, don't use it to find pOH with this formula. There is a different method to find it. And what is that method? We are going to be considering the relationship between pH and pOH before we start solving questions. Okay, what is that relationship? Now, the basic relationship between pH and pOH is simply this. How do we find it? Now, as we know, the 10 raised power minus 14 is equals concentration of hydrogen ion multiplied by concentration of hydroxyl ion. I presume everybody has been following this thing through, so you remember this particular formula. If you don't remember, just know it now, that this is what we refer to as ionic product constant of water, and this is the value. It is equivalent to this. Now, when you have this arrangement, it means that if I decide to do the negative log to base 10 of 10 raised to power minus 14, it is going to be the same thing as doing the negative log to base 10 of all these things, that is conc of H plus multiplied by conc of OH minus. Now, for those of you that have a great understanding of log reading, you will notice that this particular value, because it's the power, would multiply the log, and then you're going to have minus 14 times bracket minus log 10. So please, what I basically did is I took it out. Is a principle in log reading that once you have log a raised power x, it is the same thing as x log a. Just have this in mind. There is no other way to explain it but just knowing it. Now when you have a log of a number that has an exponent or a power, you simply take that power and multiply the log of that value. So that's why I took this guy and took him from here and wrote him here. So which means what we now have is minus 14 times minus log 10. So this is now going to be equals. Now if we expand this bracket, this is times. When you use log to open a bracket, if this is minus log times this, what we are going to get is minus log concentration of hydrogen ion. These times here, when you expand a bracket, will turn to plus. If you don't know this, it's basically a mathematical issue, and I would like you to please go back and review your log reading. However, just note that when you multiply, open a bracket of log, and it's joining two particular substances, two variables, how the times there turns into a plus once the bracket is opened by a log. Okay, so it means we'll continue. This is minus log times OH will now be minus log concentration of OH minus. Now you might not bother about the derivation and just wait till we get to the end, but it's important you somehow know what we mean. Now, negative log 10 is exactly equals minus 1. You can type it in your calculator if you're confused, but then just know that the log of a number to its base, this is log 10 now, so log 10 base 10 is 1. So what we're going to have is minus 14 multiplied by bracket minus 1 equals, now if you go back to our definition, we said pH is equals negative log of the concentration of hydrogen ion, and we said pOH is equals negative log of the concentration of hydroxyl ions. And what does that mean? Anywhere we see negative log of concentration of OH, we can replace it with pOH. Anywhere we see negative log of concentration of hydrogen ion, we can replace it with pH in this case. So here we have negative log of concentration of hydrogen ion, and what is it equals? It equals pH. So here we replace it with pH. In this case, this is negative log of concentration of hydroxyl, and negative log of concentration of hydroxyl, as we know, is pOH. So we replace this with pOH. So we continue the math. Minus 14 times minus 1 is 14, and this is going to be equals pH plus pOH. So please, class, if you are confused about this, probably your foundation about log reading is faint. But the most important thing you need to take note of or have in mind is that when you add pH plus pOH, what you are going to get is 14, which means that if I'm looking for pOH and I have a pH value, how do I get it? It means that my pH will now be equals 14 minus pOH. Hence, my pOH will now be equals 14 minus pH. So please take note of these things because they are going to be used a lot in solving. If you have questions, please ask. Yes, respond if you have questions. Okay, so if there are no questions, please just say you understand. Okay, very good. Thank you, Chuku Prizi. If you have no questions, just say you understand so that we can move ahead with the study. Basically. Okay, so I think at this point we should be able to answer one or two questions. Okay, so let's start with no, before we go to that, I forgot to say something. Yes, there's a particular and the final part before we get to solve questions. Please, I hope we've been writing down all these formulas and these things I've been saying. The ones to take note of majorly are this, these ones. So make sure you write these ones and put them somewhere, and also take note of this particular concept, this particular guy. So make sure this is written, this is written, and this is written. Just write them out somewhere because we're going to be referring to them constantly as we are solving questions. If these things are not written and I'm solving a question, you might be confused and start wondering, why did I bring it up? Okay, so let's move ahead of this and get into something else. Now, if you have a good knowledge of log reading, how are we going to now relate concentration? How to find concentration of hydroxyl ion from pOH, or how to find concentration of hydrogen ion from pH. These things are actually very simple to do. Now, without calculator. The emphasis, oh, okay, maybe without anti-log. Let's use the term without anti-log. Without anti-log. Okay, no, that's a very wrong spelling. So when your calculator does not have an anti-log, how are you supposed to solve this thing and resolve it? It's quite simple. First of all is that, let's start with that of pH. pH is equals negative log to base 10 of the concentration of hydrogen ion. So when you're looking for this guy, first of all, this minus has to go over, and then it will be minus pH is equals log of the concentration of hydrogen ion. Now, if you want to remove the log, what you simply do is the anti-log of the other one. So which means the concentration of hydrogen ion is equals anti-log of negative pH. Please put this formula down. Put this formula down. Now, whenever they say find the concentration of hydrogen ion, you simply do anti-log of negative pH. On the other hand, if they ask you to find that, now imagine we don't have a calculator. If we don't have a calculator and we're supposed to solve this, just have this in mind, that concentration of hydrogen ion is equals 10 raised to power minus pH. Put this down. This is easier to resolve. So if I tell you, okay, answer this question. What is the concentration of hydrogen ion if the pH of the solution is 5? So everybody solve this question. What's your answer? Give me your answer. This is a very simple question. How do I find it? Without calculator, that's what's the answer? Straight up, what's the answer? Put out your answers. Basically. Okay, I'm still waiting for your answers. Yeah, but besides that, please, if you are learning anything, I'm just seeing 3 likes. Go and like this video, please. And then if you have not subscribed to my channel and you are currently watching, please just hit the subscribe button. It's not hard. It's not hard. Just hit the subscribe button. And then all of you, yeah, go and start liking. Before I continue teaching, you will like this video. If you don't like it, I'm not continuing again. We will end class. All of you, go and like. I'm seeing 13, okay, 10 people currently watching. Oh yeah, till this like reach 10 before we continue class. Mona go like and sharp. Mona they do, because I know say they try, they teach something. Okay, yes, Peace Obioha, you are correct. 10 raised to power minus 5. Those are when I know the class, I be the question too hard. Okay, so I think I'm going to solve. Let me solve it at this point. Now, it's quite simple. Once they say you should find the concentration and you are given pH, simply do concentration, which is what they say we should find, of hydrogen ion equals 10. Then raise it to the power of whatever pH they give you. But then it's negative pH, not just any pH. So the answer is minus 5. 10 raised to the power minus 5. And that's that. Quite simple, I guess. I hope this is fully understood. Now, I would have to move ahead for want of time. Now, in the case of pOH, once you are looking for the concentration of hydroxyl ion, you simply do anti-log of negative pOH, or you use concentration of hydroxyl ion equals 10 raised to the power minus pOH. Basically that. So once you do this, you get the concentration of hydroxyl ion. Okay, so let's try questions. We'll try take like 5 questions. You know, the way the class is going, it be like say most of una don't go sleep, but we go do wetin we go fit do. Let's just be continuing till we become saturated. Okay, yes. Chukwuprizi Pet, you are correct. Okay, so yeah, I was about to pull up questions. Chukwuprizi Pet, you don't like this video, go and like if you don't like, if you have not liked it. Okay, so I presume we all can see the question on the screen, and with that said, the question says, what is the pH of 0.001 mole per dm cube solution of sodium hydroxide? What is the pH of 0.001 mole per dm cube solution of sodium hydroxide? Now let's get to solve this question. Now, to solve it, the first thing I said you should check for is what you were asked to find. And please, according to that question, as we all can see, we were asked to find pH. Now, the different ways to find pH is pH is equals negative log to base 10 of the concentration of hydrogen ion, or pH is equals 14 minus pOH. So any of these two can work to get pH. Now let's look at what we are given. In the question, they gave us 0.001 mole per dm cube, or molarity of NaOH. Now please listen. I hope if you all noticed that you are given a concentration to find OH and not to find H+. Which means if we happen to find the concentration of OH, because this is NaOH now, so this concentration does not have anything to do with hydrogen. It has to do with OH, so that's why we're using it. So this will be concentration of OH equals 0.001 times the number of moles of OH here is just 1. So which means the concentration of OH in the solution is 0.001 molarity. Now I hope we know why I am using this. Why I'm using OH is because they gave me sodium hydroxide, and the concentration associated with sodium hydroxide is the concentration of the base, not hydrogen, because it's OH that is in the compound. So now that we have found the concentration of OH, we need to find the concentration of hydrogen. How do we find it? Concentration of hydrogen is equals 10 raised to the power minus 14 divided by concentration of OH. And according to this question, we do have it, and that is concentration of H plus will now be 10 raised to power minus 14 divided by, now if you convert this thing now to something like a standard form or something like that, you have 1 2 3, which is 10 raised to power minus 3. Now if we continue with this, what we are going to get is 10 raised to power minus 11 as our concentration of hydrogen. Now this is the particular one that we can now add to this. Now if we decide to continue with that particular line of action, we'll now find out that our pH is equals negative log of the concentration of hydrogen, which is now found to be 10 raised to power minus 11. Now if you punch this directly to your calculator, you are going to get 11. However, let's show us one way to solve it without a calculator. Very simple. Apply the principles of log. This will now mean that this would come and multiply everybody, which means taking the power away from here, we're now going to have minus 11 times negative log 10. The minus 11 has gone over here, and that's what we have here. Now it is important that you note that log 10 is equals 1. So just have that in mind. Log 10 is equals 1. So what do we have? Oh my god, the question seems to have been blocking the screen all the while. I am so sorry about that. I did not take note of that. Whoa. Okay. Okay, so I'm going to like start afresh. I'm going to start afresh. I noticed you guys can say let me just go back and resolve that. Okay, so it's been taken out now. Okay, so solving the question from top, so we can now see. I said initially that when you are asked to find pH is equals negative log to base 10. We don't need to write base 10 now, just know it's there, of the concentration of hydrogen ion. The other formula to find pH is equals 14 minus pOH. Now we're going to use two methods to solve this question, but let's start with this one. Now according to the question, we were given the concentration of NaOH, and that is going to be 0.001 molarity. Now I would like to tell you guys and say this, that this concentration of NaOH can only give us OH concentration, not hydrogen. So let's find the concentration of OH. And how do we find it? The conc of OH will now be equals, as we know now, the concentration of the base, which is 0.001 molarity, multiplied by how many OH is there, which is 1. So which means what we can find with that value we are given is the concentration of hydroxyl ion, and it is given as 0.001 molarity. Now this is how to find the concentration of hydroxyl ion. However, hydroxyl ion cannot be added to this particular equation to solve. What we need to do is to find hydrogen ion using hydroxyl ion, and the expression is quite simple. Concentration of hydrogen ion is equals 10 raised to power minus 14 divided by concentration of hydroxyl ion, which we now have. So which means the concentration of hydrogen ion will now be equals 10 raised to power minus 14 divided by that's going to be, now let's convert it to standard form. This is 1 2 3, so this is going to be 10 raised to power minus 3. If you have issues with standard form and logarithm, please, you will need to go and resolve it and then come back to watch this video to make it easier for you to understand. Now once you divide these things through, what you are going to get as your answer is 10 raised to power minus 11. So now that we have the concentration of hydrogen ion, we can now put it in this formula and get our answer. So let's solve it. Putting it in the formula, it will now be pH equals negative log. What we now have as the concentration of the hydrogen ion is 10 raised to power minus 11. Now if you happen to impute this directly into if you impute this into your calculator, you are going to get your answer, which is 11. However, let's try solving it without the calculator. Now there are basic things you need to note to solve the log values without a calculator. The first thing is that log 10 base 10 is equals 1. Remember, this is log 10. This is log to base 10. So log 10 base 10 is equals 1. Just always have that in mind. Now let's solve this. Now if you have a power here, you should take this power and multiply this whole value. Remove it from here and multiply everybody. That's how to remove powers in log. So this is going to be pH is equals minus 11 times everything that is remaining, which is bracket minus log 10. Remember, we removed it from here and put it here. That's how to resolve it, which means that your pH will now be equals minus 11 times. Now note, log 10 base 10 is going to be equals 1. Remember, this minus remains. Log 10 base 10 is 1, and you have that. So which means the final answer of our pH will be minus 11 times minus 1, and that is going to give us 11. I presume this was understood. Well, this is just one method of solving. We are going to consider Jesus Christ. Oh, I thought I did not. Okay. Does that mean I'm going to? Okay. So far, did you guys follow, or should I explain it again? Sorry about that. Okay, I have to start over again. Oh, no worries. No, no worries, no worries. I'll start again. Okay, I think it's out now, right? Is it still on the screen? I presume it's out now. Sorry about that. My monitor screen was acting up, so I did not notice it. Sorry. Okay, so let's solve it for the umpteenth time now. So you all have to listen to the same thing all over again. Now, with that said, where are we? Yes. So we are asked to find the pH. The formula of pH is equals negative log of concentration of hydrogen ion, or pH is equals 14 minus pOH. Now, we were given the concentration of NaOH, and that is 0.001 molarity. This NaOH can only give us OH concentration. We can actually prove that. You know, when you write NaOH and you are dissociating it, what it will give is Na plus OH minus. It's not going to give you H plus. So what we can find with NaOH is OH. So let's use that. How do we find it? I told you that when you're looking for the concentration of the base, is concentration of hydroxyl ion. It is simply the concentration of the base, which is 0.001 molarity, multiplied by how many of the hydroxyl is inside. In this case, is 1. So the concentration of hydroxyl ion will now be equals 0.001 molarity. Now, having mentioned this, it's important you now note that we can use the concentration of hydroxyl to find hydrogen. How? Concentration of hydrogen ion is equals 10 raised to power minus 14 divided by concentration of hydroxyl ion. If we do this, what we are going to have is that the concentration of hydrogen ion is equals 10 raised to power minus 14 divided by the concentration of the base is going to be 10 raised to power minus 3. I hope you guys have a strong mathematics foundation. If not, please look up standard form and indices to be able to understand this fully. And what we're going to get is 10 raised to power minus 11. Please, I hope you all saw what I did. Okay, yeah, that's good. Okay, so going back to the question. Sorry, my monitor screen was acting up, so I couldn't notice that in time. Okay, so sorry. Going back to the question, we are not done solving because we are asked to find the pH, but what we just got is the concentration of hydrogen. Now let's use that concentration to find pH. That means we are going to have pH will now be equals negative log to base 10 of the conc of hydrogen, and the conc of hydrogen, as you can see, is 10 raised to power, so that will be 10 raised to power minus 11. Now we can put this in a calculator, you get your answer straight up. Your answer will be 11. But what if you don't have a calculator that has log? What do you do? Let's apply log principle here. Log principle: when you have a power or an exponent, you take that exponent and multiply the log and you get your answer. So you take this 11, put it out, minus 11 times the log. The log there is minus log 10. It's important to note that log 10 is 1, so which means pH is equals negative 11 times minus log 10 is 1, so you put 1, which means our pH is equals minus 11 times minus 1 is equals 11. Okay, this is just one method of solving it, and we're going to try out the second one. But for now, did you guys understand what we did? So please respond if you understood, so that I can move ahead. Okay, yeah, I'm still waiting for your responses so I can move ahead. If you understood, please indicate. Okay, this like never reach 10. Mona like, if all these people never like, Mona begin like. Oh, you get. And if you haven't subscribed, please subscribe. It's important you do so, because yeah, just subscribe, okay? Now, yes, please say she understood. I think I can move ahead. The rest of you, I would assume you understood but do not want to talk. So let's continue. Or probably your times of getting these things are different. Okay, now the second method of solving it is by using the other formula I wrote, which is pH equals 14 minus pOH. Now, whenever you are given a concentration of a base, you can only use the concentration of a base to find the concentration of hydroxyl ion, as I said earlier. This is 0.001 molarity. So when we find the concentration of hydroxyl ion, what you are going to get is 0.001 molarity. As we solved earlier, this is the same question. You get, so as we solved earlier, we got that the concentration of the hydroxyl ion is this. Now, instead of going through those rigorous processes, we could simply use the concentration of hydroxyl ion to find pOH, and then do 14 minus pOH, and we'll get our answer. So we'll find out that our pOH can be found, because we have the concentration of hydroxyl, will now be negative log to base 10 of the concentration of hydroxyl, which is 0.001 molarity. Now, before you solve this, please convert your values to standard form. This is going to be log 10 raised to power minus 3. Now, if you remembered what we said, this minus 3 will have 2 times. If you put this directly in a calculator, you get 3. But if you don't have a log or a calculator that has log, what do you do? Now, minus 3 will now be minus 3 times the log. What log do we have? Negative log 10. And because we have negative log 10, what are we going to do? Quite simple. We already know that log 10 is 1, so this is going to be minus 3 times negative log 10 is 1. You have this, and okay, yes, so as I was saying, so this is minus 3 times minus 1, therefore the pOH is going to be equals minus 3 times minus 1 is going to be plus 3, and you have that the pOH is 3. Now, since we are not asked to find pOH, but we're asked to find pH, what do? pH will now be equals 14 minus the pOH is 3. Therefore, what do we have as our answer? 11. Very good. So please, which of the methods do you think you understand better? I think this is faster though, but if you understood the other one better, it's best to use it. So yes, is this understood? Is it clear? Is it clear? So which do we prefer? The first method or the second method? Just comment if you are following. Do you prefer the first method or would you prefer the second method? For those of you that are following. Yes. Whichever one is actually going to give us the same thing, but you know. Okay, now I would like you guys to try out this question. Try out this question. Try this question out. Where is it? pH. Okay, so all of you should try out this question on the screen. Okay, so try out. Give me your answer. So I'll be giving you guys 1 minute or 2 minutes to do that. So in the next 1 minute or two, just send out your answers, basically. Okay, Chisom Favor says D. Let's solve. Now that I have an answer, I think I can solve at this point. So solving that is not going to be an issue. First of all, I'm going to take this question away from the screen where we don't have Okay, I presume it's out. So let's get to solve it. Let's get to solve it. So the question basically says the pOH of a solution of 0.2 molarity of HCl is dash. So in this question we're looking for pOH. So what do we do? Let's get to solve it. You are asked to find pOH. So when you are asked to find pOH, most of you can actually use calculators to solve this thing. I said because we are looking for pOH, it's going to simply be negative log to base 10 of the concentration of hydroxyl ion, or pOH is equals 14 minus pH. Now solving this is going to be quite simple. Please listen. Very easy, very simple. What did they give us in the question? They gave us the concentration of HCl, and HCl concentration was given as 0.25 molarity. Let me confirm. I hope I'm not wrong. Yes, where is it? So you guys can actually look up the question in your own end. Yes, 0.5 mole per dm3 of HCl. So yes, you have that. It's 0.5 molarity. Now remember, HCl when it dissociates cannot give OH. It would give hydrogen ion plus Cl minus. So which means we can find only the concentration of hydrogen as 0.25 times how many hydrogen is here? 1. Which means what we're going to have here is 0.25 molarity as the conc of hydrogen ion. Now using the second method, we are going to have that pH will now be equals negative log to base 10 of the conc of 0.5, but then we use standard form 2.5 times 10 raised to power minus 1. This is standard form. Now if you impute this directly into a calculator, you are going to get your answers without stress. However, let's try the non-calculator method of solving this thing. Now before you use the non-calculator method of solving it, I think there are some important things we need to know. If we can go and learn log 1 to 5, sorry, log 1 to 10, simply for the sake of this jam, log 1, log 1.5, find a way to cram it. I don't know how you're going to do it, but now log 1 is 0, log 2 is 0.301, log 3 is 0. I think is 477, log 4 is 0.602, log 5 is something. So just try to keep these things in head. You just write them out, repeat them over and over and over, and it comes into your head. That's the only way to solve this question in the hall, because in the jam calculator or with the jam calculator there is no log. So just try to cram these things and it will be easier for you. So let's continue. Now applying the principle of log, we need to open this thing first. So if we open it, pH is equals negative log, this will now be negative log 2.5. Now if this times here will turn to a plus, so that this will times this, and then we have negative log 10 raised to power minus 1. Now if we solve this, this is now going to give us pH is equals negative log 2.5 is equivalent to, now you can press this in your calculator so that you will get this. Now please, if you find a value, you use at least 3 decimal places. So this is going to be negative 0.398, at least 3 decimal places. When solving questions in chemistry, use at least 3 decimal places, 398 plus, we already know that log 10 is 1, so this will be negative. Oh, before that we need to bring down this particular guy, and we're going to have minus 1 multiplied by minus log 10. Now please, these processes I'm going through is without calculator. If you have a calculator, just impute this thing and you get your answer, but we don't have a calculator. The calculator you have will not have log. That's why we are using straightforward methods. I'm taking it step by step as much as possible. So most of you that will not understand these things are people that have issues with log. So I would advise that you probably keep flowing with the class, then go back later and review your log, and then come back to the video. It's going to be there for you to look through it again, and then you can send your questions to me directly. So you have pH will now be equals minus 0.398 plus minus 1 times minus log 10 is 1. So we are going to have pH is equals minus 0.398 minus 1 times minus 1 is plus 1. So this is plus 1. So what our pH will now be equals is 1 minus 0.398. So we'll have 1 minus 0.398. And what you're going to have is equals 0.602. That is the pH. But the question did not say we should find pH. It said we should find pOH. So our pOH, when we have a pH, is 14 minus pH. So which means our pOH is 14 minus 0.602, and that is going to give us pOH value of 13.398. Okay, so which of the options has 13.398? And that should be, let me check it out again. 13.4. Okay, approximately 13.4, and that is option B. So if you look at it, is option B. How long will the class last? The class is supposed to end by 12. What is the time now? It's almost 12. Okay, I think we'll just take 1 or 2 more questions and then we'll call it off, if you don't mind. But so far I hope this particular, if this was understood, please indicate. If you're having issues with this, also please indicate. Okay, I think I'm going to put out the final question. I probably talk about thermodynamics some other time. We'll end once it's 12 so that we can all go and take rest. But basically, I hope you guys learned 1 or 2 things. Okay, now let's look at this question finally. Let's look at this question finally. Those of you that are still online, if you have questions, please comment already. Okay, okay, nice. Okay, now I think we should try out, let's try out this one more question. Oh, before we try out one more question, I would actually like to use the other method to solve it. So let's use the other method to solve it. That's using finding the concentration of OH and then getting to solve it. I think that's now, yeah, I noticed something actually, that when you have a 0.25 value, it's best to change the concentration you get. If you change the concentration to a whole number value, you solve your pH or pOH questions faster. See what I mean? When we solve using the other method, if you are asked to find pOH, it is equals negative log conc of OH. Now, if you decide to find the concentration of OH, we'll find out that concentration of OH minus is equals 10 raised to the power minus 14 divided by concentration of hydrogen. And from this particular question, our concentration of OH minus is equals 10 raised to the power minus 14 divided by 0.25. Now, rearranging this to help us understand this more, we could have that this can be arranged to give concentration of OH minus is equals 1 times 10 raised to the power minus 14 all over 25 times 10 raised to the power minus 2. This is simply mathematics. I don't know how else to explain this, but please, if you have a foundational problem in standard form, you should please just quickly look it up look up standard form and uh, look up standard form and look up indices as well as log reading, and probably come back to the video later. It's going to be easily resolved for you. Okay, so once we have this and we want to resolve this is going to be simple to solve. What do we have now? If we type in directly this in a calculator, we will get a direct answer, but let's solve it without a calculator. Now if I happen to, this cannot go, so I add two more zeros, and once I add two more zeros, this will change to times 10 raised to power minus 16 all over 25 times 10 raised to power minus 2. If you don't understand this, just do 1 over 25. Just do 1 times this, put in a bracket, divided by 25 times 2 raised to power minus 2, put in a bracket, and then you get the same answer we are going to get. So this is going to be concentration of hydroxyl ion equals, cancelling out, this is 4, and you have 4 times 10 raised to power minus 16 minus bracket minus 2. This is indices. This is not a class to teach indices, so please, you could look that up later. Now when you do this, your concentration of hydroxyl ion is going to be equals 4 times 10 raised to power minus 14. So you have that basically as your answer. Now to resolve this, what are we going to do? We now have the concentration of OH, and if we have that, that is going to be pOH equals negative log of 4 times 10 raised to power minus 14. As I said, first of all, once you have two numbers, you need to separate them, and that is by opening with log, and that will now become pOH equals negative log 4 times 9. Oh, sorry, I told you guys that once you have a times, this times will turn to plus, so you write plus, so you now times this one, it should now be negative log 10 raised to power minus 14. Now I told you guys that you guys should at least have the logs of 1 to 10 in your head. Log 4 is 0.602, so that means negative log 4 will now be negative 0.602 plus bracket. We have to resolve this. The power has to go first, and how does it go? Minus 14 will now times negative log 10. It's a principle in log, so just know it or cram it, or however you're going to keep it in head. Now once you have this, it means that the pOH will now be equals this plus negative 14 times log 10 is 1, so minus 1 will be here, and then we are going to have pOH equals negative 0.602 minus times minus is plus, so you have plus 14, and when you do that, our pOH is still going to give us 13.398. I hope this was understood. Now the basic question I have for us before we probably call it a day, let's see, I hope you all are following, is I did it again. Okay, let me go and resolve that. Sorry, I did it again. My monitor screen is acting up sincerely. That's what's happening here. I did it again. Okay. Okay. Okay, so let me confirm. Okay. Okay, just to confirm, was it blocking? I don't think it was blocking all throughout. Just want to confirm where I should restart. Okay, so I'm going to resolve using that other method. I'm going to resolve using the other method. So resolving using the other method, I said that pOH is generally equals negative log of the concentration of OH minus, and the concentration of OH minus is simply equals 10 raised to power minus 14 all over concentration of hydrogen ion. Now I presume we all know that the concentration of hydrogen ion is equals 0.25 because it's just one, so 1 times the concentration of the acid is the same thing. So if we solve this now, this is going to be conc of OH minus equals 10 raised to power minus 14 divided by 0.25. Now rearranging this to suit what we can get, this is the same thing as 1 times 10 raised to power minus 14 divided by 25 times 10 raised to power minus 2. Okay, why I'm writing it like this is so that it will be easier to resolve. We can easily resolve these things. Okay, so if we are going to resolve it, minus 2. Okay, so with that said, if we solve this thing now, what we're going to get here is, for me, I prefer solving it without calculator. If you put this in the calculator, you get your answer straight up. But let's say we are not dealing with a calculator. What I do is I make this device double, and if I add 2 zeros here, it means that this is going to increase to minus 16 divided by 25 times 10 raised to the power minus 2. This goes into this is 4, and this is going to give us 4 times 10 raised to the power minus 16. Division means minus, so minus bracket minus 2, and this is going to give me 4 times 10 raised to the power minus 14. So just have that in mind, that this is the value of the concentration of hydroxyl ion. Now that we've gotten that, let's now put it into pOH, because when you are asked to find pOH with this formula, you need concentration of hydroxyl. So we'll use pOH equals negative log of 4 times 10 raised to the power minus 14. Okay, I presume you are following to this point. Please, if you have questions, please indicate. I think it's still okay. If you're following, please indicate so that I would know that I'm not wasting my time. Okay. Okay, now having said that, I think we can move ahead. Now, what I basically did is what we've always done. You find out that pOH sorry, this is asking for this one. Okay, so as I was saying, you find out that pOH will now be equals negative log. Now opening the bracket, this will be negative log 4. Then this times will turn to plus, and then you have negative log times this will now be minus log 10 raised to the power minus 14. And when you have this, what is going to happen? pOH will now be equals negative log 4, as I said, is 0.602 plus. When you open this, first of all, this power has to go down and it becomes minus 14 times minus log 10. This is the principle of log and how it is being resolved. So if you do this, your pOH will now be equals negative 0.602 plus bracket minus 14 times minus log 10 is 1. By now you should have known that. And then what do we have? pOH is going to be equals minus 0.602 plus, in this case is going to give 14. Now when you do that, pOH will now be equals 13.398, and that's your answer, straight up. So I presume that this was understood. Yes, you can use the other method to always solve. If you any one of the method, I'm giving the two of them so that you would know or utilize anyone you like. However, if you prefer the other method, just use it. Okay, now before I leave, or we call off this class for today, I would just like to let's just look at this briefly. Let's just look at this question finally. Let's just try this question. Okay, now before we continue, I would like you guys to answer, the ones that are still awake. Is this an acidic solution or an alkaline solution? So please put your answers out right now before I give out the next question. Is this an acidic solution or an alkaline solution? Is this an acidic solution or an alkaline solution? Is this an acidic solution or an alkaline solution? Okay. So, question is out. What do we have? There's no answer yet. Are you all sleeping? Una don't sleep. Okay, P says acidic. Chuku Pricey Pet says alkaline. Let's resolve this. Can we all go to our jotters? If you go to your jotter, I think this can be easily resolved. If you all go to your jotter, listen. We said just go back to your jotter and check out this statement. pH. Sorry about this. Pen is acting up. Okay, so we said that pH values greater than 7 alkaline, pH values equal to 7 neutral, pH values less than 7 acidic, pOH greater than 7 indicates acidity or acidic solution. pOH less than 7 indicates alkaline. Then pOH equals 7 indicates neutral. So please review this. Always note this. I don't know, I've given you guys and I presume you guys were writing. So it's acidic. Chuku Prizipet, I presume that you have noticed the correction. Now, please, can you all try this question finally so that we can all go and sleep and call it a night? We don't try. This is actually quite good. But we've touched every possible aspect. I'll still put out questions in the group to help us understand this. Okay. For want of time and to call it off already, I am going to simply solve this. This is quite simple. You were asked to find the concentration of a hydrogen ion, and you are given pH. So they said, what is the concentration of hydrogen ion in mole per dm cube of sodium hydroxide of pH this? Now if you are looking for the concentration of hydrogen ion, it is quite simple. Okay, the question says, what is the concentration of hydrogen ion in mole per dm cube of a solution of pH? That sodium there is solution. It's not sodium, it's supposed to be solution of pH 4.398. Okay, so this is going to be easy to solve. First of all is, when you are looking for concentration of hydrogen, I told you it is simply 10 raised to the power minus pH. And if the pH in that question is 4.398, you find out that the concentration of hydrogen ion is equals 10 raised to the power minus 4.398. Now please, for those of you that are writing jam, yes, there is raised to power. Oh, sorry, I think I am doing what I did before. I said concentration of hydrogen ion is equals 10 raised to power minus pH, and that's what we're looking for. Now the pH we are given in this question is 4.398. if you have this, just put it there. Concentration of hydrogen ion is equals 10 raised to power minus 4.398. in the calculator of jam, this is, you can do raised to power. You will not see log, neither will you see anti-log, but you see raised to power. So all you need to do is impute this in your calculator and you are going to get your answer. So if you impute directly, let's do that. 10 raised to power minus 4.398, 10 raised to power minus 4.398. We are going to get 4 times 10 raised to power minus 5 as our answer approximately. So if you check it, our answer is going to be option A. So our answer is option A, because what we're going to get is 4 approximately 4 times 10 raised to power minus 8. Okay, so yes, as I said, our answer, if you guys were following me, you got, possibly when you did that, you got 3.99 something times 10 raised to power minus 5, which is the same thing as saying 4.0 times 10 raised to power minus 5, and that's your answer. Okay, we'll be calling it off for the night. Thank you very much for watching the video. Please, you can review it anytime. It's always going to be there. If you have questions, you chat me up directly. Don't forget to subscribe and like. Remember, this is Wits Lounge, learning made easy. Before I leave, do we have any questions so far? The ones that are still awake, do we have any questions? If we don't, I think we should call it a night. So good night, everybody. Or should we continue?